All right, today I'm going to take you how I am going to take a mechanical 91 to 92 MR2 gauge cluster and update it to be electrical so you can do any type of swap, even a K-swap, and get the stock gauges to work. So let's get to it. So here we have a 91 or 92 stock gauge cluster, and the speedometer itself is mechanical, so any of the electronics out of a newer swap will not work for this application. So what we're going to have to do is take the speedometer out of the cluster and convert it to electrical. The remainder, the temp gauge, RPM, the battery, and the fuel level itself are all digital and can be remained and be controlled with our Haltech. So we're going to leave those alone. We're just going to focus on the actual speedometer itself for today. All you got to do to get this thing apart is there are a couple clips on the side. I've already pre-popped mine just to kind of show you, but this pops right off. You do that for the top lens and the second lens. After that, there's a couple of screws on the back side of this cluster holding just a single cluster on. Take those screws out and it will pop right out. Next, you'll completely disassemble the gauge as it was. It has this mechanical speedo on the back, and you will take this plastic cover off here. There are two screws behind it that will release this. You can completely trash that, don't need it anymore. I took a picture of the actual mileage there and then basically overlaid a picture there, so the let's call it odometer that was actually there behind it is no longer there. I then took an X27-168 servo motor out of a GM cluster and glued it on the back. And then we have essentially a digital tach or digital speedometer. In order to get all this to work, we're going to use an Arduino to power our stepper motors, and in between the stepper motors, we're going to use this TB6612 breakout board. That is an H series breakout board that's going to provide polarity protection against our stepper motor. So just these two components wired up, and then we'll get that stepper motor working. So give me a second here. I'll get it wired up and we'll start writing some code. Just to make my life easy, I'm wiring everything up with these, let's call it Arduino wires that are basically set for the header pins that are already on there. And it needs 4 power supplies, 4 5-volt lines ran to it, and unfortunately the Arduino only has 1 output. So I'm going to take one of these pin headers and just solder the bottom 4 located right here all together and make my own little, let's call it jumper harness. So stay tuned for that. And just like that, I've got 1 pin outlet 5 volts to 4 pins. So that's all you got to do there. I'm going to get some heat shrink on this and call it a day. Now we got this thing all wired up and mounted into the back of the cluster. Let's go ahead and pop open some Arduino IDE and see if we can write some code and get this needle to move. All right, here we have Arduino IDE. I've written a little code here to basically sweep a stepper motor. It's just going to sweep the full range from basically 0 to 315 degrees on this X27-168. So let's go ahead and verify this code and upload it to the Arduino, and we should start seeing this thing sweeping. There we go, just like that. So we're going to have to smooth it out a little bit with the code, but it's just going to do a full sweep. And now I'm going to go back to the code, clean up a little bit, but there's some action. So give me a second, I'll clean up some of this code. Now that we know everything's working, I'm just going to go ahead and take a simple glue gun and basically solder, if you will, or glue all of the connectors down so they don't move. All right, now that we've got everything tucked back into the actual cluster, a little bit of hot glue holding everything in place. I've got my USB running to the actual Arduino for power. Once I get into the car itself, I will do a little 12-volt to USB to power it. I've got 1 wire hanging out the back you can't see here for the input from the VSS, but essentially this is what we're looking like. So I'm going to finish up the coding to do a miles per hour from the VSS, and then it will have the position of the stepper motor on here. And that's it. That's all it takes. Enjoy.
Being that the MR2 was a tachometer driven by distributor from the factory car, we're going to have to take the high voltage system and wire in a new resistor to convert it to a low voltage system for the Haltech to drive the tachometer. It's pretty simple. There's a resistor here on the top right corner. Once you have the tach facing away from you, you just take it out and put a 10 ohm resistor in, and it should work just fine. I know I'm doing this one at a high level, but if you want something that's a little more in detail, there's a couple of YouTube channels out there. Just type in MR2 tach swap and Whistling Diesel as the individual doing the video. Does a really good breakdown on how to do a resistor swap. These prematurely are known to have failures with the capacitors in the actual gauge cluster itself, specifically on the tachometer. So I'm just going to go ahead and do a little preemptive maintenance, if you will call it that, and replace the capacitors so we're safe while I'm in here.
They're so dirty from touching that glass, dude. Your what?
My business unit. Yeah, can you get it? Oh,
yeah, you're on it though.
There's one. That was it.
So are we switching to that gauge cluster?
This is the one, the extra one it came with, and that's the one I'm modding for the tachometer. So I brought it to use it as a spare in case I fried something or got something wrong. If I was gonna mess one up, it was gonna be that one before, you know, ruin this one kind of thing. That was the idea anyways. Yeah, it was double work, but it's worth it just in case, since these are old and limited knowledge on some of the stuff. Key? I lost the keys. No, I didn't. All right, once you have the cluster finally back in the car, it's time to test it out. Haltech has a sweep function. We've already programmed it in. Let's see if it works. Looky there.
Sweeping. Like a broom.
We'll go ahead and give you a little full action here. If I can get my foot on the clutch.
You're out of here.
Just like that. Got a working tach. Seal it back up by putting the case back on it. You're all done. Slowly but surely. I'm hoping I can do this in the car. I don't want to take those plugs out again. I should have just done it outside the car. Okay. Talk about a fight. Goodness gracious.
Look at that.
Yeah. Job's done. After that, I've got a fully working cluster minus speed, but
Who needs that?
I've been in here slaving. But somebody's got to do it, you know? When you're the wiring guy.
You're the wiring wizard.
I know. Wire me up. I got no power. Are you the kind of person that hates a dead gauge on your stock cluster? Well, I'm going to show you how to fix that with a Haltech. So right now, we have a coolant temp sensor that doesn't work on our stock cluster. So what we're going to do is go inside the Haltech. We're going to actually connect our ECU to start with. Once it's connected to the computer, we're going to type in generic. You don't have to type it all in, and then start pulling up the generic outputs. I already named this one for demonstration. Turn it on, name it what you want to. This is going to be blank. Depending on your sensor type, you'll either use duty cycle or frequency. You can change the settings here on whether it's frequency or duty cycle. After that, depending on your application, you can choose a condition for it to turn on or off, like a like and or as, or use a table. I'm gonna use a table for today. Go down to condition settings. If you do conditions, here are your greater than or equal to, like and or as, but we're gonna do the table. You come in here, click the table axis setup, add the condition. So I'm going to enable one here just for demonstration purposes. Select what condition you want to utilize. As previously stated, I'm using cooling temp, so I'm going to go disable this one. Go back into your cooling temp, set the Fahrenheit or Celsius if you have it, values that you want to use for your table. Hit OK. Come back in. Change your duty cycle or frequency output to what you want it to. And I'm just gonna mess with this one real quick to show you that it works. So right here we have 20% duty cycle as an output for 75 degrees. I'm gonna type in 50 and we're gonna watch the gauge. So go ahead and show the gauge real quick. And I hit enter, look at that. We have movement. So that's all it takes. You might have to do a little playing around to understand where your duty cycles need to be, but after that, you will have a functioning gauge.